Hello and welcome to another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit number 2, Lesson number 2 on function notation. So function notation is something that you saw back in Common Core Algebra 1, but you probably didn't use that much in Common Core Geometry. Maybe a little bit here and there with, parabolas in the coordinate plane. But at the end of the day, what we'd like to do is we'd like to review this very important notation with you because you're going to be seeing it for the rest of this course. So let's jump right into it. Now, as we all know, functions are rules that convert inputs into outputs. So function notation is a lot of time written as y equals f of x. We say it as f of x, f of x. And basically, it's got everything there, right? You've got your input, you've got your rule, and you've got your output. One thing that should really be noted in all of this is that a lot of times we think of the function and the output as being interchangeable with one another because that's really what equality means, is that the two things are the same. Y and the function really are the same thing. All right, even though in a certain sense the function is itself the rule, and I guess y is the consequence of the rule. Okay, so I'm going to clear out that text, and then let's jump in and actually do some problems involving function notation to remember just how it works. All right, exercise number 1, it says evaluate each of the following given the function definitions and input values. So in letter A, it says f of x equals 5x minus 2. What's f of 3? Well, what they're really saying is that the rule is take x, multiply it by 5, and subtract 2 to get the output. So f of 3 means take 3, multiply it by 5, get 15, subtract 2, and get an output of 13. So f of 3 is 13, right? Why don't you do f of negative 2? All right, let's do it quickly. So again, all it's saying, no multiplication here. Well, there's multiplication in the function itself. But all this thing is really doing is saying, substitute in an input of negative 2 and tell me what the output is. And in this case, the output would be negative 12. Letter B and letter C are very similar. The only difference between them is that the functions are a little bit more complicated. Pause the video now and see what you can do. Try to do it, though, without your calculator, okay, to help you review some important things. All right, let's take a look at g of 3. Now, g of x is x squared plus 4, so g of 3 will be 3 squared plus 4. Don't forget your order of operations. We'll do that exponent first, and we'll find that g of 3 is 13. Well, there's a little bit of a coincidence. G of 0 will be 0 squared plus 4. 0 squared is 0, and therefore we get 4. All right, let's take a look at this one. This is 2 to the x, not 2 times x, so h of 3 will be 2 to the third. 2 times 2 times 2 gives me an output of 8. This may have been the hardest one, 2 to the negative 2. Did you remember that negative exponents mean division? Right? So h of negative 2 is 1/4. We'll work more with negative exponents later on in the course, but hopefully you remembered a little bit about them. All right, so real simple. Function notation allows us to give the rule for the function, whether it's in equation or graphical form, we'll see that in a little bit, and then ask what the output is if we're given a particular input. All right, pause the video now, write down anything you need to. Okay, clearing out the text. Let's deal with a table that's a function given in table form. Remember, functions come in 3 primary forms: equations, graphs, and tables. I love tables. Here we've got boiling water at 212 degrees Fahrenheit is left in a room at 65 degrees Fahrenheit, and it begins to cool. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours h, and that makes sense, right? If I put in the time, the number of hours it's been cooling, there is only one temperature that the water can be. Look how easy it's going to be to evaluate the function. T of 2, well, that's just saying what is the temperature when the input is 2? Well, the temperature is 104. Likewise, T of 6 is the temperature when the input is 6, and that's 68. Now, what's interesting about letter B is it says, for what value of H is T of H 76? Notice here what I'm being given is the output, and I want to know what the input is. That's always a little bit trickier, but with a table it's awesome because I scan along here, I find an output of 6, and therefore my input is H equals 4. Make sure to put H equals 4 there. Letter C, between what two consecutive hours will T of H be 100? Right, again, here they're giving me the output. One of the things that's tricky about tables, though, is I don't see a 100 in there. But I do notice that since this is cooling down, I would have to hit 100 sometime in here. So it must be between the hours of 2 and 3 that I hit that 100-degree temperature. All right, pretty easy, pretty fast. I love tables. Pause the video now if you need to, and then we'll move on. Okay, here we go. Let's take a look at a function in graphical form. Remember, these function rules, equations, graphs, tables, any of the above. Now, this might be a little bit trickier, but keep in mind that the input are x values, right? So this, and this are all x values. And the outputs are y values. So if I want f of -1, what I'm going to do is come over to an x value of -1, and the output is 0. The y value is 0. On the other hand, if I come over to an x value of 1, now my output is equal to 4. Likewise, when I have an input of 5, 1, 2, 3, 4, 5, 1, 2, 3, -4. It is exceptionally important for you to be able to do this, for you to immediately know that f of 5 is a y value, okay? What's f of 0? Well, that means the input has to be 0, and the output, f of 0, is 3. And f of 0 always is the y-intercept. Always is the y-intercept. Letter C. What values of x solve the equation f of x equals 0? What special features on a graph does the set of x values that solve f of x equals 0 correspond to? Now you have to watch out here a little bit. This one could be easily confused with letter B, right? It'd be, oh, I got a 0, got to put 0 in. Oh, no. This is the output. It's the output. It's y equals 0. Let me circle those in red. That's here, here, and here. So the values of x are x equals -1, +3, 4, 5, 6, 7, and +7. These are known as the zeros, or x-intercepts. Finally, letter D says, between what two consecutive integers does the largest solution to f of x equals 3 lie? Now again, right, that's the output. It's the y value. The easiest thing to do is to graph y equals 3. So let me do that. I'm going to do it in red. 1, 2, 3. I'm going to graph that. There's y equals 3. And here is my largest solution. And it's not exact. It's not like an exact integer. So 1, 2, 3, 4, 5, 6, 7, 8 must be between 7 and 8. All right? The other two locations where f of x equals 3, x equals 0, and x equals 2, well, those are easy, right? But that one's kind of tricky. All right, pause the video now, and then we'll clear out the text. Okay, here we go. Nice little multiple choice question. Very, very important. It says for a function y equals g of x, it's known that g of negative 2 equals 7. Which of the following points must lie on the graph of g? Pause the video for a second and think about this for a moment. I'm hoping it's obvious, but it may not be. All right. Well, I'm hoping you all kind of looked at that and said, that's just silly. That's easy. I mean, he's telling me that's the input, which of course is x. This is the output, and that's y. So the point negative 2 comma 7, choice 2, has to lie on that graph. And that's very, very important to be able to tie in function notation with what's going on with the function's graph. All right. I'm going to clear this out. Pause the video if you need to. Okay. All right, last problem. Physics students drop a ball from the top of a 50-foot high building and model its height as a function of time with the equation h of t equals 50 minus 16t squared. By using tables on your calculator, determine to the nearest tenth of a second when the ball hits the ground. Provide tabular outputs to support your answer. All right, well, let's bring out the TI-84 Plus. Okay. Well, let's go into y equals and put this equation in. Now, it's going to be a little bit annoying because in y equals, I'm going to have to put it in as 50 minus 16x squared, but we're at the Algebra 2 level. I bet we can handle it. So let's put that in. Clear out anything you might have in y1, y2, etc. And then in y1, let's type this in. 50 minus 16x squared. Now, I should set up my table. Let's go into table setup right above window. I'm going to start my table at 0 seconds. And I'm going to make it go by ones just to see what happens. Who knows, maybe this takes like a long, long time to hit the ground. Let's go into our table. All right. Now, how do we interpret this? Well, I mean, obviously at 0 seconds, the ball is 50, 50 feet above the ground. At 1 second, it's at 34 feet above the ground. But look at this. At 2 seconds, right, we're at negative 14, which means we're below the ground according to the equation. So at some point between, I guess, x equals 1 and x equals 2, we must hit the ground. But we want it to the nearest tenth. That's not good enough. So let's go back into my table. Actually, back into my table setup. My apologies. And let's start our table now not at 0, but at 1. And instead of making my table go by ones, I'm going to make it go by 1/10. All right, let's go back into the table. Now, as we kind of scroll down, what we now see is that there at 1.7, we're above the ground because our h is positive, and there at 1.8, we're below the ground because the height is negative. Now, which one is closer? Well, then it's really a question of which one is closer to 0, right? Is the height at 1.7 closer to 0, or is the height at 1.8? And it's 1.8, not by a lot, but somewhat. So 1.8 is our final answer. All right. So what I'm going to do is I'm going to get rid of the calculator. We don't need it anymore. Bye-bye. And now I'm going to clear out the text. All right. Let's finish up. So today what we did is we looked at what's known as function notation. Now sometimes function notation will be used when functions are out and about, and sometimes function notation won't be used. But when it is used, we have to feel confident and comfortable with what it means. All right, lots of practice on this as we move forward. For now, let me just thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.